Hello, everyone. My name is Nurani Nimpuno, and as my colleague Holly has said, I'm the Head of Global Engagement here at LINX. And it's my great pleasure today to welcome Jari Arkko, who will be presenting Evolving the Internet Through COVID-19 and Beyond. As explained, this is part of a series of talks with experts in the industry called the LINX Distinguished Speaker Series. And we'll be making all of these presentations and videos available online, so you can watch them whenever you want. But of course, those of you who've joined us live have the opportunity to ask a question. So please make sure to grab that opportunity and pop any questions you have in the Q&A. And I'll make sure to bring them to Jari at the end of the presentation. So let me introduce Jari. And Jari is a well-known figure, perhaps to many of you. Jari is a senior expert with Ericsson Research. He's the former chair of the IETF, which is the Internet Engineering Task Force, the Internet Technology Standards Development Organization. Jari has worked on routers, testing tools, AAA systems, AI, and cellular system networks. He likes to personally build and use the technology that he works on. And today he works on Internet evolution and 5G. Jari is a member of the IAB, the Internet Architecture Board, and a frequent contributor in matters relating to the Internet architecture and trends. He's also worked on a number of Internet administration related topics, including the IANA transition. So without further ado, I'll hand over to you, Jari, to give your presentation. The floor is yours.
Thank you, and thank you for having this opportunity to talk about this interesting topic. And also, I'm eager to see the next ones in the series. And so today we are going to talk about Internet evolution, or how the Internet evolves, particularly through the lens of what happened with COVID-19. If we go to the next slide, Holly. So we will look at past and present evolution and talk about some of the future challenges. And of course, the pandemic has been a tragic event for the world, for the individuals, for the societies. But it's also a situation where we can perhaps try and observe what is happening to some of the systems of the society, namely Internet in this case, and try and understand the impacts of sudden changes in requirements or needs for Internet services. And we'll talk about how Internet evolution happens, and hopefully there's a little bit of a positive angle there on how the Internet is evolving and can evolve, and how can we benefit from that. So I think we can move to the next slide. So let's talk first about the very high level traffic situations. And speaking to the LINX audience, I think you guys know much more about the specific numbers than I do. But just looking at sort of the immediate reactions in March, when a lot of the quarantines were or lockdowns were put into effect. So we saw significant changes in different types of networks. So fixed networks, some announced 30% increase, some 20% increase in traffic, overall traffic counts. We saw mobile network increase in different ways. Some a little bit less than the fixed networks, some a little bit more. And it's actually interesting, on the left you see a picture of or a map of Paris, and the color codes, green means a drop in traffic, and red means an increase in traffic, and white means no big change. And perhaps understandably, you would see a drop in how much there's traffic within the sort of downtown or business areas, and there would be an increase in the areas where people live at. And of course, that's also dependent a little bit on like what type of country and market you are in. Sometimes you would have the situation that there's not that much fixed networks in place. In those places, you would see a much higher increase in the mobile network growth, and in places with covering fixed networks, you would see maybe a little bit less. And so after this initial impact, you would see some more maybe predictable growth. So it sort of tapered a little bit from that point onwards. It was smoother growth or flat growth, or like the initial impact is always the biggest, and then you see a little more long-term impact that's not so radical. If we go to the next slide. So in addition to the actual traffic numbers, or in terms of calculating like how many bytes and packets and so forth, there's maybe a more interesting story about the particular services that get used. So quite obviously, the meeting services were in high demand. So you would see like Cisco report for sometimes 2 times more traffic, and some particular times of the day, even 24 times the traffic that they had before the pandemic. Microsoft reported 200% growth, and so forth. Go to the next slide. And my colleagues at Ericsson write this report called the Ericsson Mobility Report every couple of months. And the most recent edition, they had researched the use of different applications and how that had changed during the pandemic. And quite obviously, you would have things like remote working or e-learning, education apps, wellness apps, grow in usage. So on this graph, just to explain what the dimensions are. So the y-axis is about the number of users and growth there, and then the x-axis is about the use of this app as a whole. And in some cases that would go down, in some other cases it would go up. And then for things like travel or booking apps, you would see their usage go down, which is quite understandable, of course. Next slide. And so you could say that there's a fairly big immediate shift in terms of both the type of traffic and the amount of traffic. And opinions differ, of course, like how smoothly this whole thing went. And my own opinion, partially based on some of the research that the colleagues did, is that it was relatively smooth, like not a lot of complaints from users or not a lot of long-term breakage. And we could ask perhaps why. And one reason is, of course, that you had this capacity increases, like several networks were increasing capacity, several services were increasing capacity. People are also doing other improvements in the background that we don't necessarily know so much about. But in addition to those things, there's also sort of architectural things. So of course, because we had this cloud CDN deployment models, that meant that we can relatively easily move things like the particular service can grow fast, and another service can shrink, and it's not a big deal because they can all run on the same existing hardware, just a different allocation of CPUs for different services. So that's good. And I guess, of course, the internet model as such, that you have this general purpose communication service, which can be used by many types of services. And so you just have your computer and now using it for some different purposes than you were using the day before. So all of those things helped. It's also interesting to look at some of the long-term or potential long-term impact. So this is all predictions, of course, but we've seen a sort of big increase in the use of video. And when you increase the set of people who are using it, let's say the elderly or users who use video for education purposes, you would introduce more people that can actually do this or use these services. So we'd expect that they would also use it in the future, perhaps a little bit more, even if there's no more pandemic. And the same true of organizations and people. So just some particular numbers that I picked from research. One interesting piece of information was that 3 out of 4 parents thought that their children had been able to get better education because of ICT technologies than without during the pandemic. 3 out of 4 elderly persons were using video calls. It's a relatively high and perhaps even a surprising number. And they thought that it was important for their ability to keep in connection with their family. There's also likely some requirements or thoughts that people will have, or users will have, or organizations will have. And one of them is potentially the question of resiliency, or ability to have networks to actually work in different situations. And I would actually hope that people take it even more seriously now, because this is actually important, that bad things can happen. There can be fires, pandemics, floods, just regular business growth, and you actually want to have services that you can depend on, even during some special events. So resiliency, the ability to deliver services always, is maybe a thing that people will look into a little bit going forward. Next slide, please. I just want to insert a small advertisement here. So the Internet Architecture Board, the IAB, we think about things in the internet, what trends are happening, what issues there are, and so forth. And we occasionally organize workshops on specific topics, and we are just now organizing a workshop on the impacts of COVID-19 on networking. So if you have further interest on this topic, or you have perhaps experiences like how did you manage your own network, what did you have to do, we'd really like to hear about you and your experiences. So it's easy to participate. So you can submit the paper, a short position paper to the workshop. We'll talk about measurements, experiences, and as well as lessons for future. The deadline is October 9. You can find this easily at the iab.org website. Next slide. So if that's the part about COVID-19 impacts, I want to now move into a sort of a more general discussion about evolution in the past, evolution in the recent times, and talk about how that has happened and provide some examples. And there's a lot to talk about, of course. Some things are visible on the screen. There's obviously many other things to talk about outside. One thing that I would sort of highlight immediately here, that maybe 10 years ago when I was thinking about this, like how does the internet evolve? And I felt it's not really going to evolve very fast, if at all. We're always going to be, TCP/IP. We can never move from one of these protocols to another. And now, after 10 years, I think that was actually wrong. It's not the case. I'm surprised how easily we've been able to do a lot of things. So one event that happened in the last couple of years was the significant increase of encryption. So some of my mobile network customers, for instance, they said that they had maybe 20% of traffic that was encrypted before, let's say before the Snowden revelations, for instance. And then a couple of years later, they had 80%. So it went from 20/80 to 80/20 in a space of a couple of years. And that I think is remarkable. And there's some reasons for that, of course. One is sort of the observation that, hey, this is a necessary thing, that we're getting attacks, such as those revealed by Snowden, but also many other things like people's accounts being hacked and their information being spied on. Just somebody sitting at the coffee shop wireless LAN that they are in and observing what's happening, or hijacking their sessions, and that's bad. So that's one reason, but there was also many other reasons, like the increase in security happened to coincide with the need to have better control of the sort of the end user experience and better control of the service that several companies are providing. So when they provided end-to-end encryption between a web browser and the server, this enabled them to be in exact control of what's actually happening on the user's screen, which they were unable to do perhaps to the full extent in past times. So that's one reason behind this. Another reason was that there was some new technologies that were coming online that made it easier to use encryption. For instance, HTTP2 came around, which enabled you to use one security setup for many connections, and therefore the cost of security was not that great anymore. In addition to security, there's been a lot of evolution also in the web protocol stack. So I already mentioned HTTP2, just one of the many examples in that space. There's also IoT systems that use the web protocols and web model, and the integration of conversational multimedia and multimedia in general into the web. So a lot of the things that we use today are based on this. We also have seen changes in the transport protocols. So QUIC has been introduced in the last couple of years. It's already a fairly good chunk of internet traffic if you measure what traffic is going through your networks. And that's kind of the surprising thing, that you can actually take away TCP and replace it with something else. And again, some of the reasons why this actually was possible relate to the way that you can do things more efficiently. So many of these changes that have happened have provided an efficiency improvement, and together with the efficiency improvement came also some security improvements. And security was always turned on, and but the efficiency being improving all the time was a key factor for the quick adoption of some of these technologies. And then, of course, we've also had other things happen in the internet. IPv6, remarkably slower adoption, of course. I'm quite positive about IPv6, actually. It is necessary, and I myself and a lot of my customers, they actually need it for just managing their own networks. It's much easier to have an IPv6 address plan and just have one thing and be able to reach everything from everywhere than to do the necessary IPv4 tweaks. So there's various kinds of reasons for deploying IPv6, but it certainly has taken a longer time than some of these web and security changes. DNS is also an interesting example to talk about. Obviously, there's been historic changes going from the host files to the DNS itself, and various extensions to security over the years, and not a lot of evolution in the protocols themselves, like how do you query your name for DNS, except recently when more of the web technology is being adopted. So security and web technology being adopted to use DNS as well. But the security story is also interesting because early on, no attention at all to security. And then later when they came up with DNSSEC, that was mostly about, well, we need to make sure that the information we get is correct. And that was the focus. And it's a correct focus. But today, or in the last 10 years, the focus has been maybe more on can we protect the user's privacy and the user's information in some way, so that you can't actually spot in this coffee shop wireless LAN that what this person is doing. And hence we've had this proposal for introducing encryption for the DNS query protocol, such as DNS over TLS or DNS over HTTPS. And that's probably not the end of the story. We'll get to that in a moment. And I don't want to go into too much of the other stuff on this slide. There's also tons of other things happening that is not strictly technical, or is sort of technical in some other sense. It's not about the protocols of the internet. It's about cloud technologies or CDNs and such, but there's a lot of business changes there's more specialization, that compute is now in these cloud providers, and content delivery and servers are over at some other parties. There's been the mobile revolution in the background. People use apps now much more than they use browser, perhaps, at least on the mobile front. There's consolidation of the market, which is basically a negative thing, that you have like bigger and bigger entities that own more and more information, and they're more and more central to the way that the internet operates with users use the internet services. There's virtualization technology, and the way that we build stuff is different, a lot less proprietary, a lot more open source. Also standards maybe not as important in all cases as having open source. That's another alternative in some situations at least. So lots of examples, and basically the main message here is that there's has been dramatic changes in the internet in the last couple of years, and not all of it is necessarily visible, that you don't really know that, oh, the security, unless you look very carefully, you can see that the security was on. But there's also other technical change, that transport protocols are changing, and that's a dramatic change. It may not impact the user in a lot of ways, but it does provide a smoother service and more secure service and maybe more efficiency. Next slide, please. So let's talk about the speed of evolution a little bit, because the basic claim here is that the speed is increasing, and it's maybe a little bit easier to introduce changes. So just a couple of examples from different angles. So one is this like version updates of protocols, and TLS, which is the protocol underneath HTTPS, is a good example of that. The newest version, which is 1.3, got as much implementations and users and share of internet traffic in the first 5 months of its use than the earlier version had in the space of was it year and a half. So if we look at these specific updates, you can see that the newer versions get adopted actually faster, and it doesn't happen just because people want to adopt things faster, but there's actual reasons behind that, like they actually need to use it because they need the efficiency improvement, for instance. There's also been necessary enablers, like Let's Encrypt is one example of those, that now that you don't have to pay for certificates, you can actually enable security on your websites much easier. Consolidation, I mentioned it in a negative sense on the previous slide. It also can be a beneficial thing in some cases. Like when you have, one large entity decides to do something, then their impact is immediately visible. There's also cases where you have like a party, let's say Google owns 2 endpoints of the communication. They have the servers and they have Android clients, and now suddenly you can actually make a change by one entity, and then it changes a lot of the traffic. Another aspect is who can change the code, and this is now not about this open source versus proprietary, but I'm thinking of a different aspect, which is the kernel versus user space. So some of these changes that we've seen in the last couple of years, like Quick, is about moving things from the kernel, where it's sort of relatively stable but also difficult to change, like TCP. You move it to on top of UDP processed in the application space. Now, all of a sudden, if you want to update the transport protocol, all you need to do is push a new version of the browser or whatever application that you're using. And then that's it. It happens overnight. You could not do that for all the kernels in the internet system as easily. Also, there's protocol engineering tricks. We use cryptographic. We explicitly designed the protocol wire image so that this information should be used, and then this information should not be used. And now all of a sudden, middle boxes can't look at this should not be used part of the information, and therefore, any middle boxes can't be on the way to break something or prevent the change to be done, as they have been in a lot of cases in the past. Let's go to the next slide. So let's talk a little bit more about this evolution, and when does it, how does it happen in the best possible ways, and also I've had a lot of interesting discussions with other internet friends about whether the internet was designed to evolve well or not, and opinions differ. And in some ways, I'm in the middle of those opinions that it doesn't really matter in some sense, because you the internet that we have today is is surviving and is changing because it's the way that it was designed. Whether it was designed that way for the express purpose of evolving or not doesn't really have an impact. The impact comes from its ability to evolve. And two specific things make it easily evolvable. One is obviously modularization, because you have separation between the network and the applications, and naming from other connections and transport from other things. That enables easier evolution, of course. The other thing is that the internet was designed to be a general network. It was not designed to be the most optimal thing at 1970s technology or 2020 technology or whatever. It was designed to be sort of it's good enough and general purpose, not specialized, not super optimized for any particular situation, but it just works well enough. Means it's relatively easy to change it or apply it in new situations. So the keys for successful evolution, of course, you need to solve a concrete and immediate need. You need to have business incentive alignment for everyone who has to make a change. It typically implies that you don't want to involve anybody else than you absolutely have to. And you also need to have a community with people who are actually implementing this, are testing it. You need to have applications that are adopting it. You can't just sit, like I sit in a research organization. If I were to just convince my research people that, well, this is a neat change, but I wouldn't convince the the Facebooks of the world to adopt something, then it would be sort of pointless, because it would be difficult to get the idea actually moving in real deployment. Next slide, please. And we've actually written about these deployment issues in the past. There's an RFC about it, RFC 5218. Thaler and Bobova were the people behind that, and basically states that there's this important things initially, which is this basically about this immediate need, very positive net value, and that you can deploy incrementally. And then some other things are a little bit less important, perhaps. And then if you want to have like wild success, that like the web that has covered the world and is used for almost everything. The reason for its success, for this wild success, is that it's so extensible and so usable for many different problems, and there were no hard scalability limits or any other major problems, and in some ways good enough security, although you could debate that, but it's been improving in the last couple of years. And I don't think I want to go into too much detail here, but you could try and analyze based on this some known technologies and how well they match these requirements from the RFC, or these ideas about successful evolution. And I think you can see the results in the speed of adoption also. Let's go to the next slide. So so far this has been about what evolution there has been, and that the evolution can actually happen quite rapidly. Now I want to talk about what's coming up against us, and what are some of the things that we should try to find evolution in. And there's of course plenty, because the internet is so important and we have so many requirements for it. And the first thing on my list is security. And usually when we talk about security, people want to go into this encryption or that encryption or the protocol details. And I want to up-level that discussion just a little bit. It's not just about communications security. It's also about what's happening at the endpoints. So if you look at today's statistics about internet security problems, they are largely about data leaks of data at rest, unintentional data leaks, but also, of course, some intentional ones. We really need to think about this better than we have so far. So a lot of the internet technology development has been about, let's encrypt more information that we're communicating in these packets. And I think we've almost gone the way, like, of course, that's still an important thing to do, but we've almost gone all the way on that path. And now we have to find the next things that are the next battlegrounds in this security against people who want to take our data. And it needs to be about data at the servers too. Like, do you want to actually tell this or that server something that they may later leak? One good example of this is DNS. So we first worried about the integrity of the results coming from it. Then we worried about revealing DNS queries to outsiders. But now we should actually worry about whether we want to tell this particular DNS server what we are asking, making like we would rather do something to make sure that those servers do not become the next source of information that can be used in collecting information about users. Another aspect is I guess sort of outgrowth of this COVID-19 impact, which is the resiliency and ability to withstand all kinds of problems, whether they're sort of natural disasters or denial of service attacks. And I think there's plenty to do on that front also. Obviously, performance is still a key issue. One of the things is that now that we have these capabilities in these new transport protocols and we can change them overnight, what should we do with that? Can we use that to boost the performance? And that's going to be obviously a thing that many people continue to look at. So it's interesting to see what happens there. Device diversity, we will have more and more diversity in the set of devices, not just my computer and your computer and the server, but all those IoT devices and different classes. And some live 20 years or 30 years on the network, and then my laptop may live 2 years or 3 years. So there's a lot of diversity in the way that these things what these things need from the internet. Consolidation already mentioned. I also want to mention another term, centralization, which is about putting everything in the network into a central, at least logically central place, like one provider does all of this in the world. And then when that one provider goes down, we are in a world of hurt. Sometimes when we talk about this stuff, we also get questions about things like QoS, clean slate designs, and so on. Programmability was the third item on my list here. I wanted to say a few words about that. So QoS has been problematic in many ways. So we've had lots of success in providing quality of service or differentiation solutions on sort of like local networks or local accesses that you buy this gold service or bronze service or whatever, and you get a different amount of bandwidth for the different services, and that has worked quite well. But sort of end-to-end QoS solutions have been troublesome. There's a great paper by Dave Clark and Casey Claffey. Casey is going to show up in this series later, so look forward to what that is about. But the issue has been typically that the business aspects of some of these arrangements are not so clear. So it's not only about technology, you also have to solve some of the business issues that, okay, so you have some protocols between parties in the internet, but how does the business negotiation go? Can you actually make the world ecosystem, business ecosystem handle these transactions? And so the people who provide a service get their fair cut. And that's usually been the problem. Clean slate, of course, very important, interesting research. And exciting technologies, information-centric networking comes to mind, for instance. But but it's been, I guess the experience in the internet is that it's difficult to deploy totally new things. It's always easier to change the current system. And so maybe the answer is that we should look more into how can we implement ideas rather than let's throw this away and replace it with something totally new. And then programmability, it's also been interesting. We've seen a lot about that in the last 10 years. I kind of have mixed feelings about it, because now we are in a state where we can basically program everything. Like I can run whatever in whatever cloud entity. But on the other hand, we also have a situation where the traffic is very opaque. Like you can't see what's, what traffic this is. Everything's to the HTTPS port on Amazon, right? You can't really differentiate on the packets. So we'll see where programmability gets us. We go to the next slide. And I want to wrap up fairly soon, so I don't want to spend too much time on this, but it's important when we talk about possible ideas that people have, that we look at those critically, and there's tons of things to get right and tons of things to possibly get wrong. We talk about the right things on previous slides. Warning signs, if you try to do, again, my research hat on, if I don't convince the users, then it's all for nothing. I could try and force people to do something based on a top-down approach. If the IAB told everybody to, change the internet in some way, they would not do it unless it was in their best interest. Yeah, I think we talked much about this already. The main thing is that the details actually matter. If you look at some examples of different developments or proposals for developments in the internet, you will see some examples of the details, like the security improvements in DNS, for instance. Like you have to understand what are we protecting against, and what are we not protecting against. And sometimes you see that people are pushing for something that gets them out of the problem, but may not get the user out of the problem. And so you do have to look at that. And there's also a lot of technical proposals. I was recently looking at something where the core idea was that, well, we need this better security that's always on in internet communications. And that was kind of flawed in two different ways. Like one is that we already have this situation that almost everything is protected communication security wise. That's not the problem. So we're sort of replacing something that already exists with something that provides roughly the same capabilities. But another problem was that the statement was that we need security and privacy and avoid surveillance. But if you look at the details of that, then they end up using a cryptographic mechanism that actually requires a third party that knows your keys. So if you take a critical look, you will realize that, well, they're not just taking away ability to observe some people's traffic, but they are actually adding a new entity that could potentially observe that traffic, and that would be bad. So we want to avoid that kind of examples. Next and last slide, please. So summary, the internet is alive and kicking. It's quite remarkable. At least I'm quite positively surprised how much we've been able to do in the last couple of years, and then the fact that we can actually do these changes even faster now. We could roll out new transport protocols overnight. That's just mind-boggling. Maybe also a little bit worrying in some ways. And then changes that don't have this, clear demand, clear business incentives, they might be a little bit more problematic, might not happen at all, or they may go slowly. So I am at least looking forward to what's happening in this space going forward. The evolution is ongoing quite rapidly. There's many opportunities, but also the challenges that were mentioned. And then the last advice is that you should not believe what is said on the internet, even about the internet. And that includes also, whatever I'm saying, please doubt that and critically evaluate what I'm saying. But anything that's happening around the internet or that's being proposed, we do need to take a critical look at that and understand what the implications are. It's important to understand what problems we're trying to address and if whatever we're trying to do actually solves them or not, and if we can actually get it deployed. So I think I'll stop here. I've already used, I think, too much time.
Great, thank you very much, Jari. That was a very interesting presentation indeed. And it covered a lot of ground. And I think for someone who works at an exchange point, it was interesting also to see how the internet responded to the traffic surges. We certainly saw it at our exchange, but I think the interesting thing about what happened certainly at the start of the pandemic was also that it revealed the vulnerabilities, the weak spots, while I think it proved the resilience of the internet, but it also showed, for example, where there was a lack of infrastructure, the last mile. For example, I thought it was interesting to hear from some of the African IXPs that they actually saw a decrease of traffic at their exchanges because people were working from home and were then relying on the mobile network instead because they didn't have fiber to the home. So I think it's interesting to take that forward as we look at the challenges of the future and see how we can make sure that we can ensure that accessibility for everyone and can continue to develop the infrastructure that we need. I have a few questions from the audience, so I'll start with those and then we'll see if I can throw in some of my own at the end. So one question from Alexandra Kulikova. Jari, do you have a feeling of where in the world the actual adoption of evolving protocols tends to happen faster?
Yeah, that's a good question. And I'm wondering whether I should respond in a geographic sense or in some virtual sense. And I think the answer is more about this virtual thing, that some types of applications are evolving faster than some other things, and some entities can do maybe faster than some other entities. Like obviously anything that's sort of entirely web-based and you can just deploy from a very central location, have an update that happens quickly. So, and of course, like large entities that control a lot of the traffic could push changes like they have, like Google has had initial versions for Quick and HTTP2 fairly early on. So these entities can push changes in their own networks or their own users relatively quickly and early. So that's sort of the virtual answer that, in these particular cases or for these particular services or entities, it's faster.
Okay, well, thank you for that. And then one from Lauren Curley. You mentioned the consolidation in the internet. Andrew Blum talks about how the hyperscalers are completely changing the way the internet is operated and developed. What are your thoughts on that? What consequences will this dominance have for the future of the internet?
Yeah, it's a good question. I also see it in my own business, like how that's changing things. Yeah, as with everything else, it's a good thing to have, these cloud services came about because we actually need them. So that's a good thing. It's a bad thing if we have like too small set of providers for any, for your bread or for your cloud services or for your cars or whatever. So we do have to watch that. And one of the impacts in our field in particular is like if you have entities that are able to tie themselves too tightly to their service, that, well, now I'm using this service service A and I can't switch to B because I'm using the APIs from A. And so I think one answer there is that if we can push, if the users are strong enough, they can push for standards, they can push for open source, they can push for things that they can build on and they are able to switch. And that's hugely important. That's been successful in many cases, obviously in the technical world. So I don't see why we couldn't do this even better than we're doing it now in the cloud space. But that's an ongoing issue.
Right, so it's if I want to take that question a little bit further, it's also a challenge to this model that we always promote as being sort of at the heart of the internet, the distributed, the collaborative model. And we've always talked about that that's the strength of the internet, right? And not having a top-down or not have a centrally managed system. But if we take that further, then that consolidation, if it leads to, you know, a few players controlling more and more of the internet space, the cloud, the infrastructure, the delivery of services, all those things, then that could be a challenge to that collaborative distributed model, wouldn't you say?
It can be, but there's also positive examples of that not happening. Like take Quick, for instance, and how it came from Google, and they might have, like, you know, tried to own it and control it, but they actually took it to the, you know, worldwide community, and now there's, like, I don't know, 20 different implementations, and you know, working through with hundreds of people working on stuff from different aspects of the industry and many companies. I think you know, the whole thing came stronger. Like, you know, you had a proposal that had some security holes and it wasn't really suitable for everybody's needs. Now we have something that is. So I think that, you know, maybe a model to follow in also some other cases.
Okay, yeah, interesting. I'm going to throw in one of my own questions as well. And it follows on the previous questions about the distributed collaborative model. And I completely agree with your point that it's what has made the internet so flexible and adaptable. So as changes happen and new needs develop, the internet has responded to that. And I think you give the examples of the invention of DNS and CIDR, etc. But couldn't you also argue, if you want to play devil's advocate a little bit, that the distributed and collaborative model have also actually resulted in has made it hard to implement DNSSEC and IPv6 broadly, so to speak, that it relies on each party, each player taking their responsibility, and particularly with IPv6, that's been a very slow process. We're seeing some changes now, but when I worked at the RIS in 1999, we talked about how IPv6 would just be widely distributed everywhere in the world, and it would happen tomorrow. So would you like to comment a bit on that and share your reflections on that?
Yeah, I think it's a good question, but I think maybe placing the blame a little bit on the wrong side here. It's not about the distributed collaboration so much. It's typically about, like, fundamental things, like take DNS security as an example. That, well, you know, it's a useful thing, but I think part of the reason why it hasn't been as widely deployed as some of the other things in the world is that it's also sort of a, you know, add-on, like you already have or after the DNSSEC was developed, other things came around, like TLS and HTTPS, that enabled some of that functionality, some of that security to be done, and they sort of surpassed some of the need for or filled some of the need for DNSSEC, and that, I think, is the fundamental reason why it's going on maybe a little bit more slowly. I still would like to have secure DNS infrastructure, don't get me wrong, but I think it's more about these fundamental things than about who designed it. Even if we didn't have a collaborative model, pick IAB, pick any large entity, the UN or anybody, and have them command that now you have to do X, and let's see how well that goes. I doubt that
right.
There would be a different result, maybe worse result in fact.
Yeah. No, well, that's often I think when you look at some of the criticisms of how the internet has been governed in the past, it's often a little bit unclear. It's easy to criticize the existing model, but I have, at least to date, not seen any other model that I believe would function as well. So it doesn't mean that it's not possible, but I guess those who criticizing the existing model are free to put forward something else that will work a lot better than what we have today. Okay, well, I'm very conscious of time that this has taken us to the top of the hour, but I do want to give you talked about the challenges in the future for the internet a little bit. I just want to give you the last word to say anything about the future of the internet, if there are things we should watch out for, if there are principles we should take with us, or any last thoughts or reflections that you want to share with the audience.
Yeah, I'm optimistic about the future, obviously, but if there's anything that I worry about or that keeps me up at nights, it's the security piece, and in particular the security in this broad sense of how do we, who owns data and where does it get distributed. I know we already have solved to a large extent the communication security problem. That's no longer the issue. The issue is elsewhere, but it's a big issue still.
Yeah. Okay. Great. Well, thank you very much. With that, I will thank everyone who participated in this webinar, and any one of you watching this afterwards online. We'll make it available on YouTube, and we'll share it from the LINX website. As I mentioned, this is part of a broader series of distinguished speakers in the industry. So take a look at the LINX website for any of the upcoming presentations. We've got a heap of fantastic presenters coming. And it's also worth mentioning that we will have a follow-up panel discussion that touches upon part of some of the things that Jari has presented today, talking about the challenges of the internet's evolution and adaptability. And Jari will be on that panel. We'll have Jeff Houston from APNIC, Casey Claffey from CAIDA, and Andrew Sullivan from the Internet Society, ISOC. And that will happen next month, the 22nd of October, I believe, and that will soon be up on the website as well. So keep an eye out for that. And with that, a particularly warm thank you to Jari for this fantastic presentation, and for making yourself available and sharing your great insights and thoughts when we need them the most during this strange online virtual time. So thank you very much, Jari.
Thank you.
And with that, I will hand you back to Holly from the LINX marketing team. Thanks.